So far in last two sessions, we were discussed about the discrete distribution. What do you mean by discrete distribution? Discrete distribution is nothing but point level distribution. We are talking about the particular point. Now, today we are going to talk about the continuous data. First of all, what do you mean by continuous data? Continuous means some interval level data that is having some range. From ideal range of continuous data is plus infinity to minus infinity. Ideal range of continuous data minus infinity to plus infinity. So it doesn't tell about the particular point, it will tell about the range. It doesn't tell about the particular point, it tells about the range of the values. It can be, for example, what is the temperature today? We said that 25 degrees. Does it mean it will be the same for the entire day? No, it is not same for the entire day. It is from minimum, some minimum value will be there, some maximum value will be. Maybe we quoted in the summer season, we might quote about the maximum value. In winter season, what we do, we generally talk about the minimum value. So that means it is having some minimum value as well as the maximum. So that means the range. For example, 10 degrees is the minimum value, 25 degrees is the maximum value. So it can be 10.1, it can be 10.2, it can be 10.999, it can be 11.5, or it can be 24.9 also. Anything the value which is talking with the 2 points or to discuss about the 2 points is called as the continuous data. Continuous distribution has been classified into 4 different types. Continuous has been classified into 4 different types. Those are normal distribution, second one is T distribution, third one is F distribution, fourth one will be the chi-square distribution. Okay, first let's talk about the normal distribution, then we'll talk about the T distribution, and then we'll talk about the chi-square as well as the F distribution. Okay, normal distribution. Other name of normal distribution is also called as a Gaussian distribution. Other name of normal distribution is also called as the Gaussian distribution. Okay, if you want to perform the normal distribution, we generally use in continuous data. We will generally use in. Okay, if you want to understand the normal distribution, first we need to understand the sum property. How do you say whether particular data is a normally distributed or not? First point, how do you say particular data is a normally distributed or not? How do you say particular data is normally distributed or not? Simply we can say by using the mean is equal to median is equal to mode. If mean is equal to median is equal to mode, then simply we can call it as a symmetrical data. Symmetrical data is nothing but normal distributed data. How do you say particular data is a normally distributed? Mean is equal to median is equal to mode. Mean is equal to median is equal to mode. Simply we can say it is a normally distributed data. Let me talk about this in detail. Okay. Let me talk about this in detail. Okay. Okay. Mean is equal to median is equal to mode. Simply we can say it is a symmetrical data. How does the symmetrical data looks like? Symmetrical data looks like as a bell-shaped curve. Symmetrical data looks like a bell-shaped curve. It never touches the x-axis. Symmetrical data looks like a bell-shaped curve. It never touches the, this is the x-axis, this part, this down part, the down the line. It never touches the x-axis. This is the bell-shaped curve. So symmetrical, this data around its mean. This is the mean value. Mean is the mu, median, as well as the mode. So simply we can say that normally distributed data is a symmetrical around its mean value or median value or mode value. Normal distributed data is symmetrically around its mean value. Mean is equal to median is equal to mode. That is called a symmetrical data. Symmetrical data looks like as a bell-shaped curve. It never touches the x-axis. This is the line that we draw. That is the x-axis. Symmetrical data is normal because what do you mean by symmetrical data? Mean is equal to median is equal to mode. That is the meaning of the symmetrical data. Symmetrical data around its mean value. So it may be mean value is the same or median will be the same, mode will be the same. Simply we can say symmetrical normal distributed symmetrically around its mean value. It can be a median value also. It can be mode value also. Now let's talk about in detail about the bell-shaped curve. Let's talk in detail about the bell-shaped curve. Okay, let's talk about the bell-shaped curve. This is the symmetrical around its mean value. Here the first point in the bell-shaped curve. Here mu minus 1 sigma to mu plus 1 sigma. Total bell-shaped curve. This is the total area under the curve will be. Total area under the curve will be AUC. Area under the curve. Area under the curve will be 100%. Total area under the curve will be 100%. Total area under the curve will be 100%. Total area under the curve will be 100%. Okay. First, if you have doubt, let me write down. Total area under the curve. Under the curve means under the bell-shaped curve. Under the bell-shaped curve will be 100%. Okay. Total area under the curve will be 100%. Out of 100%, what is the different ranges it can be are there? Out of 100%, what is the different ranges will be there? Here mu minus sigma to mu plus sigma. Mu minus sigma to mu plus sigma is nothing but out of total area under the curve is how much? 100%. Out of that, 68% of the total population range is out of 100% data. 68% of that data range is in between mu minus sigma to mu plus sigma. Out of, in total area under the curve, in total area under the curve, 100%, first 68% of the data, first 68% of data is in the range from mu minus sigma to mu plus sigma, mu minus sigma to mu plus sigma. In total area under the curve, 100%, first 68% of the data is in the range from mu minus sigma to mu plus sigma. Okay. Next range here, mu minus 2 sigma to mu plus 2 sigma, which is the range from, I mean this entire range. It will be 95%, mu minus 2 sigma to mu plus 2 sigma, the range will be 95% of the total population. Mu minus 2 sigma to mu plus 2 sigma, the range will be 95% of the total population. Here mu minus 3 sigma to mu plus 3 sigma, mu minus 3 sigma to mu plus 3 sigma, the range will be 99.7% of the total data. Mu minus 3 sigma to mu plus 3 sigma, the range will be 99.7% of the total data. Okay. Let me write down in detail about these points. Any questions who are online?
No, Koti.
Okay, thank you. Okay. Here total area under the curve will be, total area under the curve will be 100%. Mu minus sigma to mu plus sigma, the range will be 68% of the total population. Mu minus 2 sigma to mu plus 2 sigma, the range will be 95%. Mu minus 3 sigma to mu plus 3 sigma, the range will be 99.7% of the total data. Any data point, any data point which is not falling under the range of mu minus 3 sigma to mu plus 3 sigma, those are called as outliers or extreme values. Any data point which is not falling under the range of mu minus 3 sigma to mu plus 3 sigma, those are called as the outliers or extreme values. Any data point which is not falling under the range of mu minus 3 sigma to mu plus 3 sigma, those are called as outliers or extreme values. Okay, sir. Now here few more points about the bell shape. Here half of the in the bell normal distribution, in normal distribution, half of the left side will be equal to the half of the right side. In normal distribution, half of the left side will be equal to the half of the right side value. In real time, if you want to perform the normal distribution, at least you need to have minimum number of observations are 30. In real time, if you want to perform normal distribution, minimum number of observations will be 30. In real time, if you want to perform the normal distribution, minimum number of observations should be 30. In linear data, if you want to apply the normal predictive modeling, your data should be, your continuous data should be a normally distributed. Let me write down that point also. In predictive modeling, your continuous variable should be normally distributed. How do you say it is a normal distributed or not? If mean is equal to median is equal to mode, simply we can say it is a normal. Or if you draw the bell shaped curve, from the curve also we will get to know. If your data is within the limits mu minus sigma, mu minus 2 sigma, or mu minus 3 sigma, then also we can say it is a normally distributed, right? Now the mathematical formula for the normal distribution will be 1 by sigma into 2 pi into e to the power of minus 1 by 2 x minus sigma whole square. Mathematical formula, sigma is nothing but, here sigma, this is the sigma is nothing but standard deviation. Here pi is the standard value 3.14. Here x is the individual values. Mu is the mean. Again sigma is nothing but SD. SD is nothing but standard deviation. Here first 1 by sigma into square root of 2 pi. Sigma is nothing but standard deviation. X is the individual value. Mu is nothing but mean value. Sigma is nothing but standard deviation. This is the mathematical formula. We are not going to use this formula. We have a separate formula for the standard normal distribution for the statistical purpose. We are not going to use at all this formula. This is the mathematical formula. We have one more formula. We are going to use the we are going to use the standard normal distribution formula, that is equal to z is equal to x minus mu by sigma. Z is equal to x minus mu by sigma. Here Z is the normal distribution, representation. X is the individual value. Mu is the mean value. Sigma is the standard deviation. Z is equal to x minus mu by sigma. Z is equal to x minus mu by sigma. The normal distribution range is from, ideal range of normal distribution should be no, it is the continuous data normal distribution. What is the ideal range of continuous data? Minus infinity to plus infinity. The ideal range of normal distribution also will be ideal range of normal distribution is also from minus infinity to plus infinity. Ideal range of normal distribution is also from minus infinity to plus infinity. Okay. Now let's do a one formula. Let's do a one lab session. How do we do this one? Okay. And then after we will discuss about the further points about the normal distribution. Okay. We did not complete it. We have to complete lot many things we need to cover. Okay. Okay. Assembled computer. Let's say you are working in a hardware shop. Assembled computer. So you need to assemble a computer. If you want to assemble a computer, you need to assemble a computer with a mean of 50, and sigma is nothing but standard deviation is 15. And what is the probability? What is the probability to assemble a computer? What is the probability to assemble a computer in between 40 to 60 minutes? What is the probability in between 40 to 60 minutes? They are working in a computer assembled with the mean of 50 as well as standard deviation, that is sigma is nothing but 15. What is the probability to assemble a computer in between 40 to 60 minutes? In between 40 to 60 minutes. Okay. Let me repeat the question. You are working in a hardware shop. You would like to assemble a computer with the mean of 50 and the standard deviation of 15. What is the probability to assemble a computer in between 40 to 60 minutes? Okay. Now let me go with an answer. So as I mentioned the point, first point, continuous data should be in between the range of 2 point, let's say minimum value is A, maximum value is B. It should be less than or equal to f of x, less than or equal to B, right? For example, let's say measure the temperature. Temperature will have the minimum value, temperature will have the maximum value. Let's say what is the temperature today? What will you say? 25 degrees. Is it exactly the 25 degrees? No, it can be some minimum value, it can be some maximum value. So assume that minimum value as A, maximum value as B. So it should be within the range of A to B. So A less than or equal to f of x less than or equal to B. The same way here also we need to write A less than or equal to Z less than or equal to B. Right? I'm coming. So what is the range we need to set? 40 to 60. So we can simply write A less than or equal to x minus mu by sigma less than or equal to B. So simply 40 minus mu is the 50 here. Mu is nothing but 50. Sigma is nothing but 15 divided by 15 or less than or equal to x minus mu by sigma less than or equal to 60 minus 50 divided by 50. So because why we got the 50 40 answer, we need to assemble the computer in between 40 less than or equal to z less than or equal to 60. So here what is the answer? Minus 10 by 15 less than or equal to x minus sigma less than or equal to 10 by 15. That implies 10 by 15 is minus 2 by 3 less than or equal to x minus mu by sigma, that is nothing but z, less than or equal to 2 by 3. Right, sir? Is everyone is clear? Minus 2 by 3 less than or equal to z less than or equal to 2 by 3. Okay. Now what we need to do, okay, let me write down this in simple other fashion. Minus 2 by 3 less than or equal to z less than or equal to 2 by 3. As I said, the half of the left side will be equal to half of the right side. So if I draw by using the graph, can we draw this is the minimum mean, median, mode. This will be the 0 because 0 point is the median point. This left side is the minus values, this is the minus value, this is the plus infinity. This will be minus 2 by 3, this will be plus 2 by 3. So can I write like this? Minus 2 by 3 less than or equal to z less than 0 plus 0 less than z less than or equal to 2 by 3. So what I did, first from this point to this point plus this point to this point, that is nothing but total this point only. Why we are doing, the reason is in the normal distribution, when you look, when you studied the 10th standard or 12th standard, I did not exactly remember 10th, 11th or 12th standard, In your mathematics books, backside of your mathematical books, you might have seen the appendices. In appendices, normal distribution table, like a T table, student distribution. Those tables are not in the negative value. Those are in the positive value. So that is the reason we are trying to convert them into positive way. We are trying to convert them into the positive way. Okay. The reason why I am converting the negative values into the positive values is that in the student distribution tables, the values are in the positive, their values cannot be in the negative. So we need to convert them into the positive. So simply, as I mentioned, half of the left side will be equal to half of the right side. Half of the fundamental rule, half of the left side will be equal to half of the left side will be equal to half of the right side. So simply that means the distance between from minus 2 by 3 to 0, the distance from minus 2 by 3 to 0 will be exactly equal to 0 to 2 by 3. The distance between minus 2 by 3 to 0 will be exactly equal to 0 to 2 by 3, because half of the left side will be equal to half of the right side. Simply we can write like this: 0 less than or equal to z less than or equal to 2 by 3 plus 0 less than or equal to z less than or equal to 2 by 3. So simply we can write 2 into 0 less than or equal to z less than or equal to 2 by 3, because I am adding the 2, right? 2 times of this value will be the same value. And if you look into the table of that, manually cannot calculate this value, whatever the probability value in that point. So simply 2 into z less than or equal to 0.66. 2 by 3 is nothing but 0. What is the probability value in between this range? Check that value from the table, calculate into 2. Automatically your value, you get the probability value. Clear, madam? Satish. Here half of the, let me repeat again the sub question. Here first point, as I given that you are working in a computer hardware shop with a mean 50, to assemble a computer with a mean 50 and the standard deviation is 15. What is the probability to assemble a computer in between 40 to 60 minutes? So to assemble a computer, what is the probability? Now the first, if you want to perform the normal distribution, you need to remember the few points. Those are: first point, your data should be a symmetrical data. What do you mean by symmetrical data? Mean is equal to median is equal to mode. Mean is equal to median is equal to mode will be your symmetrical data. Next point, the data looks like the bell-shaped curve. In the bell-shaped curve, half of the left side will be equal to half of the right side. What is the formula for the normal distribution? Z is equal to x minus mu by sigma. So as per the formula, a less than or equal to f of x is less than or equal to b. So because the continuous data should be in the range between minus infinity to plus infinity. A is the minus infinity, b is the plus infinity. So it will be the range of minus infinity less than or equal to a less than or equal, f of x less than or equal to b. So 40 in our case minimum value, 40 less than or equal to z less than or equal to 60. 40 as per the formula, 40 minus 50 divided by 15 less than or equal to z less than or equal to 60 maximum value, minus mean is the 50 divided by sigma is 15. So we got the formula minus 2 by 3 less than or equal to z less than or equal to 2 by 3. As we mentioned, half of the left side will be equal to half of the right side. In this case, minus 2 by 3 less than or equal to z less than or equal to 0 plus 0 less than or equal to z less than or equal to 2 by 3. So the distance between minus 2 by 3 to 0 will be exactly equal to the 0 to 0 to 2 by 3. So simply we can multiply the 2 into that. If you want to get the probability value from the go to the table, it is not impossible to go to the table. So how do I perform the same thing in R? Because if you want to get the probability value manually, we cannot get the probability value. It will be really difficult to calculate the probability value manually. So what we need to do? We need to calculate by using the R. How do I get that? The formula. Any questions before I go into the R formula? Any questions, guys?
Yeah, got one small question.
Yeah, sure, Shiva.
Actually, we have taken between 40 to 60 minutes, right?
Yes.
If you will take like 40 to 70 minutes, then is there any change in mu value and all?
Mu value will be the same.
Okay.
We said that mu value is the 50, right? Maybe in the current interval we have taken the 40 to 60.
Yeah, 40 to 60. If you will take 40 to 70 minutes, then
if they change when they are given the business problem, if they change the mean value, automatically it will change.
okay. Okay, thank you.
Yeah. Any more questions, guys?
Hi, Kopi.
Yeah. Tell me, Amar.
Actually, first we have to check mean equal to median equal to mode, right? But we didn't check here, right?
That is the general case of normal distribution. Here we don't have any values or data set to check the mean is equal to median is equal to mode. By default, we have a mean value, mode value. They clearly say that data is normally distributed. Whenever we are doing the real-time data, if you want to perform the normal distribution in reality, also I said the one point, minimum number of observations should be 30. As a rough point, how do we perform mathematically? Just as an explain that point.
Oh, okay.
Because we cannot write all the 30 points manually to calculate one by one, right? So that is the reason I have taken as an example point of this.
Okay, thank you.
And how do I perform the
The data value also completely will be same.
yeah.
But the data will be displaying in left side, will be showing in negative values.
Yeah.
The right side will be positive values.
Yes.
How we are calculating in the two types in the positive values?
So only the distance is the same. Here, for example, the probability value 0 to 2.3 will be exactly equal to 0 to minus 2.3. So here, ideally, we say the negative values. Ideal range minus infinity to plus infinity. So here the 2 points is nothing, but when I look in the probability, you look at the 0 to 2.3. Again, there is no negative values in the normal distribution. Always the positive values only. Positive value only. Now, the syntax of, in how do I write syntax in R? Pnorm is the cumulative normal distribution. X value, comma, mean, comma, SD. SD means standard deviation, comma, lower dot tail is equal to true. That means it will give the lower side values. Lower dot tail is equal to true means it will provide us the probability values for probability of x of lower side. For example, x is the 10 value. It will give the probability of 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Lower dot tail is equal to false means it will go to the higher side values 11, 12, 13, 14, 15, 16, 17 and so on infinity. Okay. Now, how do I write the formula? how do I write the syntax for our case? How do I write the syntax for our case? Here in this case, okay, here the range is in between 40 less than or equal to f of x less than or equal to 60, right sir? Mean is how much? 50. Sigma is nothing but 15. So in this case, if I want to write the formula, P norm 40 mean is equal to 50, SD is equal to 15, lower dot tail is equal to false, minus P norm of 61 mean is equal to 50 comma SD is equal to 15 comma lower dot tail is equal to false. Can anyone guess why I have written like this? Because we need to check the range between 40 to 60. If I take the first case, P norm of 40 comma mean is equal to 50 comma standard deviation is equal to 15, lower dot tail is equal to false. That means it will consider the values from 40, 41, 42, 43 and so on till infinity. So it will include 41, 42, 43, 44, 45, 50, 55, I mean 51, 52, 53, 54, 55, 56, 57, 58, 59, 60 as well as 61 and so on, infinity as well. But what is the range of the points we required? We doesn't require after 61. We required only the points in between 40 to 60. So that is the reason whatever the values which is more than 61, we should not consider it. P norm of 61 comma mean is equal to 50, SD is equal to 15 comma lower dot tail is equal to false. So whatever the values in the both sides will be minus, will be 0 only. P61 of above one as well as the 61 of the below one, both are the same. So minus of x minus x will be, both will be the 0 only in this case. So this equation will give us the in between 40 to 60. Because the reason, if I mention the 60 here in the case, it will also consider 60 onwards. 60 minus 60 it will become 0. We need to get the 60 also, right? If I mention the 60 here, the values will start from 60, 61, 62, 63, 64 and so infinity. The above one we required up to 60. Exactly 60 also we required. Yes. So is it everyone is clear? Anyone in the call, is it clear, or any questions about this?
Goody, can you open that screen?
Yeah.
The first one I got it. The 40 lower the tail equal to false. That means lesser than 40.
No.
0 till 0.
No, lower dot tail is equal to false means it will go upper side. Lower dot tail is equal to true means lower side.
But previous cases you told lower dot tail means it will be the for example lower dot tail 4 comma lower dot tail means the below the 1. That means 3 to 1 should be
in all the cases
false, right?
Lower dot tail in all the cases so far we have mentioned is equal to true means lower side only. Lower dot false is equal to means always from the starting onwards we are mentioning the upper side only. Clear? Here lower dot tail is equal to false means always from the starting onwards when we are discussing about the binomial distribution or Poisson distribution, from that point we are discussing Poisson distribution onwards, we are discussing lower dot tail means is equal to false means upper side. Lower dot tail is equal to true means lower side. By default it will take lower side only. Lower side is equal to true only. Lower dot tail is equal to true only. Okay. Now let me talk about the one more example. Okay. Okay. There is some twist in this. My question will be, you have to correct me answer. Okay. In a classroom, in a class exam, there is an annual exam is happening for the 10th class students. 10th standard student annual exams happen with a mean of 72. Data is normally distributed. Mean is 72. SD is the 15 point. What is the probability to getting marks 84 or more? What is the probability of getting marks 84 or more? What is the probability to getting marks 84 or more? So here, what is the, how do I write this one? What is the minimum value? What is the 84 to? Anywhere did we mention that marks will be maximum 100? How sure are you about? Maybe 150, maybe 200 also, maybe 1000 also, right? Generally, of course, in the 10th standard, by default, you think everyone will think about the 100 marks, but we never mentioned that marks will be for 100 marks. It can be 150 marks, it can be 120 marks, it can be 200 marks, or it can be 1000. But we are not sure. Then how do I do? Huh? That is the range of the value should be there. But we are not mentioning the range, right? We don't know the maximum value, right? If you know the maximum value or mean value, everything we can get to know about the mu minus 3 sigma, all this thing. We don't know the point, right? Then how do you decide about it? How do you do? How do you write the syntax for this one?
Lower tail equal to true.
Lower tail is equal to true means what will happen?
It go to 4 to infinity.
Let's say, let me 84. Let's say P norm. The people are suggesting 84. So 83 we need to write. Okay. Let me write 84. Sorry. Let me write in other sheet. Mu is equal to 72. Sigma is the 15.2. We need to find the probability 84 or more. Right? So the people are suggesting that P norm of 84, mean is equal to 72, SD is equal to 15.2, lower dot tail is equal to true. That is what people are saying. What does this value will give? It will give the 84, 83, 82 and so on up to the 0. But what is our question? 84 or more. Then, so this is not the correct way. So can I write like this? 1 minus P norm of 83 comma mean is equal to 72, SD is equal to 15.2, lower dot tail is equal to true. So in this case, what happens? 1 means the total probability will be should be equal to 1. Total probability should be equal to 1 minus. So what they ask the question, 84 or more than 84. So that means we doesn't consider 83 or up to 0. You may get that out. So, is it possible to have an exam marks in the negative? Ideally, no one will conduct the exam marks in the negative. Always it will be in the positive only. So, 83 onwards, 83, 82, 81, 80, 79, like that, we will go up to 0. We will go up to 0. So the total probability should be equal to 1. 1 minus this one, we will get the whatever the probability we are going to get. That means this is the probability we are going to get the more than what is the these are the probability we are going to get 84 or more than 84 marks. Yeah, conducting exam marks, minimum marks should be the 0 only, right? Starting point will be the 0 marks only, right? I mean, how many marks people got it? I'm not asking about. Exam conductor, what is the probability getting 84 marks or more? Minimum will be the 0 marks only.
But the probability rate will be always 0 to 1, right?
Probability rate, yeah.
But in this case, normal distribution range will be incorrect to minus.
No, continuous data range, I said. If the variable is a continuous variable, the range will be minus infinity to plus infinity, ideal range. There I'm not talking about the probability value. There I talk about the just variable, continuous variable. Any questions who are on the call?
I
Yeah.
couldn't able to understand this lower dot tail equal to 2. That concept I couldn't able to understand.
Lower dot tail is equal to true means lower set the values.
If you explain me through some diagrammatical, it will be good for me, I think.
Huh? Here, so for example, here this is the value. For example, this is the value. Assume that this is the 0, 50, 100. Assume that just an example. Let's say lower side means of the 50. What will be the values? Lower side means 50, 49, 48, 47, up to it will go to 0. Higher side the values of the 50 means 51, 52, 53, 54, like that. By default, whenever we are calculating the probability values, here we are calculating in terms of the range values, right? 84 we said. So lower side of 84 will be 83, 82, and so on. It will go to the 0. Higher side of 84 means 85, 83. So if I mention the lower dot tail, this is a syntax. This is a keyword. Lower dot tail is equal to true means it is going for the lower side of the given value. Lower try means it will go for lower.
But why we need to go for lower side? We need to find the find SD for 84 or more, right?
84 or more. But in this case, what is the exam marks? Are you sure? You are not sure about the exam marks for 100 marks, or maybe it can be 150 marks, maybe 200 marks, maybe 300 marks, maybe 400 marks, or 1000 marks, or 10,000 marks, or 1 lakh. We are not sure about it, right? So ideally it will go 84 or more than means it can be go up to infinity, right? So instead of finding the values 84 or more, we can just total probability value will be equal to 1. So if you calculate lower side less than 84, that means 83, 82, 81, and so on, it will go to the 0 only, right? If I remove from the 1 is the total probability value. 1 minus, if you remove the probability values from 0 to 83, whatever the probability value we are going to get, that is the probability value of 84 or more than 84 marks.
Okay.
Clear now?
If you reduce that, you will be getting the answer.
Yes. Is it clear?
Then what about this 40 to 60 range?
Yeah,
40 to 60 range.
yeah, in the 40 to 60 range. So we need to consider the only the range of 40 to 60, right?
Correct.
So in this case, what will happen? We can write like 40 comma mean value sum. How much we discussed? 50. Sigma is sigma is nothing but standard is 15.2. Of course, you need to write the SD. Comma lower dot tail is equal to true. So here in this case, what happens? We don't know the values of the up to 40. It will consider 40, 41, 42 and so on. It will go to the infinity. If I go to the next value is minus 61, mean is equal to 50, SD is equal to 15.2, lower dot tail is equal to true. So it will go 61, 62, 63 and so on infinity. But ideally what happens, the 40 will consider 40, 41, 42 and so on, 60, 61 and so on infinity will be. Next value we are going to start with the 61, 62 and so on infinity. Here the value is going to cancel it, right? So we are going to get the only this portion of the data.
Okay, I got it.
Is it clear now?
Yeah, clear now.
Okay, thank you. Where? Which case? Lower dot false is equal true, right? Sorry, lower dot false. Sorry, lower dot tail is equal to false. My mistake. My mistake. Okay, maybe typo mistake. Okay, now we are saying from the starting point onwards, we are saying the one value. The thing is that if you want to, each and every data should be in a continuous variable. The data should be a normally distributed data. What do you mean by normal distribution data? Mean is equal to median is equal to mode. If in case my continuous variable or a variable doesn't become a normal distribution, means mean is not is equal to median is not equal to mode. Then what we need to do? We need to go with the variable transformation. If our data is not normally distributed, we need to go for variable transformations. If our data is not normally distributed, we need to go for variable transformations. How? There are the various variable transformations. Those are log transformation, exponential transformation, square root, cube root. Sixth one will be Z distribution. If our data is not normally distributed, we need to go for variable transformations. How do we do? Here we have a log transformation, exponential, square root, cube root, Z distribution. Okay. When should I go with the log transformation? When should I go with the exponential? When should we go with the square? When should we go with the square root? When should we go with the cube root? Or Z is equal to x minus mu by sigma. Log transformation. If mean value is greater than median value, left side data, that is the left skewed data. Mean value is greater than means left skewed data. Then we need to use the log transformation. Exponential means mean value is less than median, so that means right skewed. Median is a greater than, basically right skewed. Then we need to apply the exponential distribution. Square root, cube root, zigzag kind of data, like zigzag kind of data, like this data will be zigzag kind of data. So basically sine wave, cos wave forms. Sine waves, when you see the hospital, there is a meter will be there checking the BP. Sine waves, I did not know the meter name. Sine wave form kind of thing. Those are called as the two. Data looks like that. We will use the square root or square root or cube root. I'm not sure which one I need to apply. I don't know anything. Then the best way to not transform the data is by using the formula z is equal to x minus mu by sigma. Best way to transform the data for unknown data. Best way to transform for unknown data. Best way to transform for unknown data. These things we are going to use in the next coming chapter. This is all about the normal distribution. Simple. Next one is a t distribution, which is 2 minutes only. In the normal distribution, what we said, data should be mean is equal to median is equal to mode. Half of the left side will be equal to half of the right side. And how many number of observations should be there in reality? 30. More than 30. What if our number of observations in the real time is less than 30? But in general cases, this is the data world, it never happened. But if you remember in our childhood, we use this distribution. In our 10th standard or 11th or 12th standard, we use this distribution. In the mathematical writing, we have to, as an example, we need to write manually. So it will be really difficult to write 30 numbers in more than one page. So we are going to use the formula called t distribution. T distribution, other name of t distribution is also called as student t distribution. T distribution or other name of t distribution is also called as student t distribution. The formula is very simple. T is equal to x minus mu by sigma by square root n. Square n means number of observations. But in reality, we never ever use this distribution. Simply, if someone asks in interview point of view, why do we use the t distribution? To compare the average of, the averages of two groups or samples. We will use t distribution. To compare the averages of two groups or samples of two groups, we will use the t distribution. Okay. To compare the average of two groups, we are using. There is no formula for the t distribution. This we will get in the regression equation. There I will show you how do you get these values. For this explicitly, like how do we do the binomial distribution, there is no such kind of formula. When we are doing the regression analysis, there I will talk. Now next is the chi-square as well as the f distribution. Before we are going to discuss about the chi-square as well as f distribution, we need to cover the some more topic, because there is some background is required for the chi-square distribution as well as the f distribution. Based on that, we will discuss about the chi-square distribution as well as the f distribution. That is all for